Hi, so today I'm going to explain a basic DC series circuit. DC is just direct current, and that means that you're dealing with a battery. The longer side is the positive side, and the shorter side is the negative. The current flows from positive all the way to negative. That's how the current flows. The current is in amps. And that's the movement of electrons in the circuit. In a series circuit, current is constant because it really has no place else to go. There's no other path for it to flow. And also, voltage is additive. So if I add a total of 15 volts, the voltage across this 2K, 3K, and 4K have to add up to 15 volts. If I put 15 volts in, I have to dissipate 15 volts out. So these three voltage drops must add up to this total. This is usually E total, and this is usually V for voltage drops. And we use Ohm's law, E, I, R. E is for voltage, whether it's the source voltage or the voltage drops. You can use them interchangeably. I is for current. Current is in amps, and that's the movement of electrons. R is for resistance, so the resistor values. This is a schematic of three resistors in series. If you want to get the voltage or the current, you cover what you want. So let's say, for instance, I want to get I. I cover I, and it's E total divided by R total will get you I total. If I wanted total resistance, it's E divided by I gives you R. If I want E, it's I times R. So current times resistance. To get R total in a series circuit, we simply add them up. So 2K plus 3K plus 4K is what? 9K, right? So to note that, we put 2K plus 3K plus 4K equals 9K ohms. When we add the plus signs, we know that they're in series. In the next video, we're going to do parallel, and when we combine those, we will use parallel lines to signify that those components are in parallel with each other. So right now, we have R total. So R total equals 9K ohms. So how do we get I total, which is the current? Well, if we cover it, E divided by R total gives me I total. So if we take 15 volts divided by 9K ohms, okay, so you take your little calculator, 15 divided by 9,000, you should get this. 1.67, because this third number is a 6. You move that up to 7. And when you get an exponent -3, it's in milliamps. So current is always in amps. It could be milliamps, which is exponent -3. It could be microamps, which is exponent -6, or just amps, which is just regular amps. So right now, we took E total divided by R total, and we got 1.67 milliamps. So that means in this circuit, we have 1.67 milliamps flowing through this circuit. So you say to yourself, well, what's the current through this 2K? 1.67 milliamps. What's the current through this? 1.67 milliamps. What's the current through this? 1.67 milliamps. So now, because current is constant in a series circuit, we want to get the voltage drops. We cover E. So it's I times R gives you E. So that voltage drop. I times R gives you E. That voltage drop. I times R gives you E. These three voltage drops must add up to 15. So let's do it. So if we take 1.67 milliamps, and that's exponent -3, times 2,000 or 2K, we get 3.34 volts across that 2K ohm resistor. We do it again, 1.67 milliamps times 3K, we get 5.01 volts. Last but not least, 1.67 milliamps times 4K, and we should get 6.68 volts. In order to check to make sure you're right, you would add 3.34 volts plus 5.01 volts and 6.68 volts, and it should be around 15. This one I got 15.03. It's going to be off a little bit, but it should be pretty close. You shouldn't get 16 or 18 or 10. So that's a series circuit. And remember, in a series circuit, current is constant. Current is in amps because there's no path for that movement to go. It's like a little whirlpool. Okay, hope it helps. Bye-bye.